Hello, good afternoon. Myself Adrian Xavier, and this is my project mate Bharatwaj, and another one of my teammates is Mazud Gori, the one who's taking this video. So today is a pleasant day to introduce our project, and we named it as Environmental Sensor Unit with Wi-Fi module. So our main objective of this project is to create a low cost and reliable environmental sensor unit. So even though there are many environmental sensor units in the market, it's very costly. And to install a very costly environmental sensor unit in a building like colleges, hospitals or server room is not advisable. So we came up with this idea to develop this unit with a very low cost components which are very reliable. So here we are using two sensors and one Wi-Fi module to transmit the data. The sensors we are using are DHT22 sensor, which measures temperature and humidity. And to measure the pressure, we are using ESP8266 which measures pressure. And ESP8266 is our Wi-Fi module, which transmits data from the environmental sensor unit to the computing system. So this is our kit and this is our circuit board. Our environmental sensor will be working with dual power supply, one from direct power socket, the other one is with a 9-volt power supply, 9-volt battery power supply. So whenever there is a power failure, it automatically connects with the 9-volt battery supply and it keeps on transmitting the data. So this is our compact enclosure, this is our breadboard. Now the working process will be explained by Mr. Bharatwaj.
This is the schematic of our environmental sensor unit, which contains the sensors such as MPX4115A pressure sensor, which is connected to the port RA0 of PIC microcontroller, and this is called DHT22 sensors, which stands for digital humidity and temperature sensor, DHT. This is connected to the port RA1. Okay, and this one sends analog values, and this one sends the digital values. This is the 3.3 volts regulator that is used for powering up the Wi-Fi module, ESP8266 Wi-Fi module. And this is our enclosure, which contains the power circuit, dual power circuit, such as a DC jack and a battery. When a power supply is given to the DC jack, it gives 5 volt. In case of power failures or interruptions, the battery, the power will be given from the 9 volts battery, which is connected here. When the power supply fails, this will continue to avoid further interruptions. And these on this side only the sensors, these two sensors will be placed. If you see in this hole means, you can find that two sensors will be placed here. Here pressure sensor will be placed, and here the DHT22 sensor will be placed. Okay, and these 4 poles is designed for placing the PCB layer or a PCB of this environmental sensor unit as shown here. This is the design. Based on the dimensions, it is displayed here with so and so values, and all the components which are connected in this breadboard will be placed in this portions and fixed here. So after that, we are closing it and mounting it on the wall. And the output of the process will be explained by Masood.
Hello Professor. So far my team has explained about the working condition and the need for the project. I, Masood Gori, will be explaining the actual output, what the prototype will be delivering. The prototype will be delivering 3 values every 15 minutes. One is pressure value, temperature value and the humidity value. But for the demonstration purpose, what we are going to display is, we are going to display the values every 1 minute. And as you can see in the Terra term, we are getting the values such as 24 degrees of humidity, 23 degrees of temperature and 100 kilopascal of pressure. This is the indoor temperature value because we are in the college building. But once we go outside, we can get the actual outdoor temperature as well. The prototype is supposed to deliver the output to a server where we can get, where the consumers can look into the HMI part But unfortunately, our ESP program was not successful, but we could not display the data on the server, so we are displaying it on the Teratum as well. The HMI was designed by our team, as you can see over here. It was supposed to display the values in such a way where it was user friendly, but we could not work with our HMI part, so we are displaying on the Teratum. Now Professor will go out to the area and will record the outdoor temperature for the demonstration purpose. Professor, we are now in the outdoor area of the college, and we are testing our prototype. As you can see, the output values for what we are getting is humidity is 36%, temperature is 15 degrees Celsius, and the pressure value is 100 kilopascals. And as compared to the weather network, we are getting the approximate value. And so that we can say that our prototype is functioning properly. The only problem what we had was the transmitting it to the server via Wi-Fi. Thank you for your support and guidance, Professor. As we can now say that our project is concluded. The only part is the ESP8266, which can be added as a future reference. Thank you again, Professor.
Thank you, professors, for your support and encouragement.